Hi, I'm Sven. I work at Liquid Reply as an, at the moment, lead developer. And I like Kubernetes, WASM, coffee, and I have an adorable daughter. So that's me.
And hi, I'm Christoph Vogt. I'm also working for Liquid Reply as a managing director. I'm living in lovely Hanover in the middle of Germany. And I'm super interested in the Kubernetes, and therefore I was founding together with my colleagues Max Körbecher and Alexander Bayer this company, Liquid Reply, which is focusing exactly on my main interest, which is Kubernetes and helping people to succeed with Kubernetes. And when I'm not working or fulfilling my hobby, I also have two daughters, and they keep me busy during the time I'm not working. So Liquid Reply, as I said, is a consultancy. It's a sub-company of the Reply Holding, and the Reply Holding is like a consultancy for basically every engineering topic that you can imagine. So this might be blockchain, this might be programming of iOS and Android apps, but also, of course, in the area of cloud computing. Yeah, as I said, Liquid Reply is focused on cloud native computing. We have the strong opinion that things that can be built on the cloud should be built in a cloud agnostic manner. And therefore, when we consult our companies, of course, we help them bring their workloads on the cloud, but not only with the managed services of the cloud providers, but also we're tending to use tools of the Cloud Native Computing Foundation. Usually our clients are either on the way towards cloud or already have a Kubernetes cluster somehow running and need some support with it. So this might be optimization purposes, this might be migrations, this might be like a bigger development platform around it. And this is basically where we are usually trying to help our customers. And with our recent topic and the topic that we are talking about, which is WebAssembly, is basically a research topic that we are currently looking into. And we found that this is a more emergent topic. I remember this talk from KubeCon North America in 2021, which was basically more or less the trigger point when we got interested into it by a company, a consultancy called Red Badger. And they're showing a really interesting showcase of what's possible with it. And by then we started also to look more into it.
Awesome. Mm-hmm. All right, so let's cover, you've mentioned cloud native, and Kubernetes a couple of times now. So let's talk about how you both got into the cloud native and Kubernetes space.
Yeah, so it's hard to say, back in the days when we just had Docker containers and were deploying them and managing all the connections between them by hand. And it was still the time where the orchestrators were competing against each other. And then, I would say for us, out of nothing, Kubernetes appeared and get a huge share of the market, and the adoption was incredible. We all had FOMO and thought, oh my God, when you're not on Kubernetes, you are doing something wrong. And then we just jumped into that, and that's how I got into the space. And then I guess you all know as well, the rabbit hole is open. You fell in, and it goes on with Prometheus, metrics, security, and so on, and one to another. And that's where we are right now.
And I basically started in 2018 working for an e-commerce company. And they were running everything on AWS using Elastic Container Services. And it was good by then. And I was just intrigued by all the Kubernetes news. And it was a buzzword. And I was looking into it. And then I started experimenting with it and starting some smaller migrations of using the existing workloads and running them on Kubernetes. And it was somehow working. But my company decided to stick with ECS because basically we didn't have any actual issue or any scaling issue with it. So it was fine for this point in time there. But eventually, my before mentioned colleague Max approached me and said that they are currently working for a very interesting automotive client, and they need someone who's living close to Wolfsburg to help this client and be someone who's from a location perspective a little bit more closer. And this was my opportunity to actually go and show what I already learned with Kubernetes and build one of the biggest clusters that ever maintained so far. And it was like a super interesting journey, specifically given that this was like, again, still very early days with a lot of bugs that we covered in the Kubernetes side, on CNI side, on storage side. So a lot of things that you now Google and basically you find the solution. You somehow had to find a workaround. And this is how I got into the topic and started doing it.
Awesome, thank you. Yeah, I think my journey was very similar. I adopted containers. Those were magic to me. I was like, this is really cool. And I actually kind of went all in on Mesos first.
Yeah,
I really liked Mesos with Marathon. I thought they were a wonderful combination. And I just completely disregarded Kubernetes because I thought it looked too complicated and I didn't really understand why there were so many different types and options. And I was like, nah, that's never going to work. And even though I liked Mesos and Marathon, I moved away from it to Docker Swarm because I had trust in the company. And I actually took Docker Swarm to a few different organizations. Was like, this is the future. We have to do this. We have to do this. Mm-hmm. And then eventually conceded and was like, all right, Kubernetes is winning. Better learn this thing. And it's been painful ever since. But in a good way, right? Like Kubernetes is hard. It is evolving. It is changing. But there are a lot of benefits to bring it into our infrastructure.
I think there was a short time where there was some kind of overlap, similar to like the browser wars. There was like these three competitors, and everyone was like talking about them and like showing how to use them. But eventually, Kubernetes emerged as the succeeding winner in a way.
Yeah, I still don't know why.
Of course.
But it's clear from speaking to both of you now, right? You've got a lot of experience with containers. These are container orchestration experts. So you help people with this stuff. Why the hell are you in the WebAssembly ecosystem now?
Really good question. So in 2020, I broke up with the JVM. So we had a long, good time, but it was over. So I started here at Liquid and jumped into Go, and recently looking into Rust. So just
nice.
Broaden the field of programming languages and go deeper into that. But the good old promise, compile once, run anywhere. So was still, I would say, itching. And when we saw it the first time, WebAssembly, it was like, wait, I can not only run JVM languages, I can also run Go, I can also run Rust in it, I can run any language independent from the processor architecture or my platform. And it was this, I would say, wow moment. We all know WebAssembly isn't totally there yet, so you can run these languages. It could be better developer experience, and it could be better integrated, but it's on the way. So you see it constantly evolving. You see more and more languages. Something where I'm at the moment very excited about is Go support. So real Go, not only tiny Go, and Kotlin support with the garbage collection enabled. So it's still excited. It will be exciting in the future. And that's how I got to WebAssembly. I'm a developer, so I develop usually on Kubernetes, with Kubernetes. So even extending like operators, CIDs and so on. And to having containers that you can just throw at a cluster and do not need to think about the architecture or something sounds like a good thing.
Like when you ever run a Kubernetes cluster on the Raspberry Pi, there was likely the chance that you ever tried a container workload, which was not like about to start because of the processor architecture, right? And this is like when you actually think about, okay, how do I need to compile my container? A container is nice. It's a nice packaging format and everything, but in the end, you still need to think a lot about like where it's going to run. Of course, we can assume that things are like more emerging towards a general standard, but in the moment, at least, we are living in the world of mainly x86 processors, ARM processors, and there might be potentially like even more specialized processors in the future. And yeah, from this perspective, a compile target, which is like running on all the architectures, is like just very beautiful, very very nice thing, and very very approachable. However, Sven, you already said it. Like you're a developer, and I think this is the main contrast. Like when you think about the perspective, because Docker and containers is exciting both parties equally, like the ops guys as well as the developer guys. And I argue currently it's more like the developer guys that are very excited that they can write code which is running everywhere. And I think ops guys up until now still need to be a little bit like more convinced. And I think this is exactly like the journey that we see, that we are currently starting to see, and that we will see like in the next months and years, when like the technologies and orchestration technologies are evolving, when we can do better debugging, when we can have very low starting time for WebAssembly modules and this kind of stuff, until we get also the ops guys very, very excited about the topic.
I've just taken a note for a question, so I can come back to it in a second.
Yeah, sure.
Because, really, it's great the way you're both describing why you got into WebAssembly. And I want to talk about that run once and the local development experience versus containers. Do both of you use Mac or use Linux users?
Yeah, so we are developing on Mac.
Yeah, okay. So we're all going to have the same frustrations, but we'll come back to that because I want to do a wee circle here, and it's like you shared a lot, right, about your history with the JVM, and you shared about Kubernetes and different container orchestrators, and you strike me as very competent back-end developers. And I'm assuming you haven't pivoted to writing web applications, right? But you're using WebAssembly. You're using WebAssembly. Maybe you could tell me a little bit about server-side WebAssembly and what's the maturity of that? What's it like right now to write a server-side WebAssembly application?
Just to rephrase the question. So have you worked with WebAssembly in the browser, and what's the maturity of the backend side?
Well, yeah, I'm assuming you haven't switched to being web developers, right? But you're now using web technologies, and I'd love to know about that transition from writing.
Okay, got it. So basically, I have developed web applications and some apps, and so I'm really not good at it. So your assumption is right. I'm a backend developer, and I can do front ends, but they look like if a backend developer would create a front end. So
black text on a white background.
Most likely. So since it's mostly white background and black text, because you need to change something to get black background, and CSS is not my strength. But yeah, the assumption there basically is right. And in the maturity of WebAssembly in the backend, I would say you can just compile your code, do a hello world, and everything is nice and fine. When you learn about the WASI, so the WebAssembly system interface, and say, hey, this is my set of APIs I can use. Basically, like in the browser, where I have fetch API, I have APIs for local storage, everything is fine. And when you start with this expectation and use your WASI, then you see, okay, May is a little bit limited, and the proposal is already in a beta state, and this implementation is not really according to the specification. And after learning that and finding the, I would say, specifics of different platforms, you see the ones who are more on the standard, the ones who are more experimental. They have cooler, newer features, but they are not according to the standards. So there's always a trade-off you need to make to see, do I now use the standard API and limit my application to the possible things? Or do I want to use the more experimental UI, and it may get refactored later to a standard, and that would break my app. So in terms of maturity, it could be better.
Yeah, of course. One must argue that companies like Fermion and wasn't Cloud or Cosmonic behind them, or like the project of WasM Edge, and all of them are like contributing not only like to the spec, but also like they have their own implementations, and they're driving the entire community and the research about the topic forwards. Of course, like from a user perspective, things could always get faster. But you see like a lot of development in this, and when you dig into the communities, you see people are very, very busy in getting the things right, and especially when we think about security, the security model of a WebAssembly is very, very promising, and I think like waiting maybe a couple of months, or hopefully not years, longer to get like a little like better development support is definitely worth it. And I think it's just like a like exploration phase, right? We are currently still exploration what we can do and how we should do things, and until things finally end up in the standard, hopefully.
All right, so let kind of bring it back to that DX question then. Server-side WebAssembly is a thing. It's improving. We have WASI, we have the component model, the capabilities of building even CLIs or server-side applications, anything with WebAssembly is now getting there. But a common question I see from people is just, why? Like, why would I go and learn this new thing? Like, we have containers, we can run them locally, we do all these things. And you already kind of covered this, right? But even with containers, we still have to worry about architecture. If you've got a dynamic or interpreted language, you have to worry about file system syncs on a Mac into a Linux container-based system. How does WebAssembly and server-side WebAssembly improve the developer experience? And feel free to speak from your own personal experience of building applications.
I totally agree. That's something I heard as well. So why should you use WebAssembly? So we have containers. It's a sandbox. But when you look exactly at it, if you configured it right, it could be handled as a sandbox. But if you have a root container, you can just walk out of the root container and are on the host system. That's, I would say, different in a WebAssembly sandbox, where you, if you don't have the API, can't just leave your environment. On the other hand, sure, there are different approaches to get the same things like WebAssembly. For example, if you want to have a polyglot environment, Zig is doing a very good job in, for example, compiling different programming languages together. You could have all the different capabilities of WebAssembly in other spaces, but in WebAssembly, you have them all together in a nice package, and you can run it on your local WebAssembly interpreter. You can run it on a SaaS offering on Kubernetes. So I really like this seamless integration into other things. You can just write plugins where WebAssembly is very, very strong. For example, in your Istio service mesh or something like that. So I would say, not yet omnipresent, but the one that we hope that will come is something that I really like about it and where I see the strength.
I mean, I would just emphasize that from my perspective, it's definitely the security model of WebAssembly, which is like most promising from my perspective. If you have ever run a Kubernetes cluster, you know what knobs you need to turn off in order to make the thing secure. Multi-tenancy is something I would not recommend, at least if you can avoid it. And Sven mentioned that container breakouts are still a thing, right? And having a entirely isolated runtime, it's just like very, very like appealing to me. And there are probably a lot of companies and a lot of use cases that can make use of this kind of like elaborated security model, would benefit from it, and where I would recommend it as well. Nevertheless, at least like from what I can see right now, I don't think that WebAssembly will take over the entire world. I think there will be some, not only niche, but there will be some part which just makes sense to write in WebAssembly, and there will be still this part where you will still compile for your average compiler, average processor. So, but who am I to see the future, right?
Awesome. Yeah, I think that's really, really interesting. I like that you said, like, it's not going to take over the world. And I agree. I think hybrid architectures are probably in our short to midterm future, at least. And we're seeing this in the cloud native landscape already. We're seeing projects come in under the CNCF as sandbox projects, right? There's the WASM Edge runtime. There's WASM Cloud. There is some other projects adopting WASM as an extension model. what's the Red Panda, right? So it's a Kafka replacement that has a WebAssembly runtime embedded into it for doing transformations on your streams. We're seeing the project from Loft, the JS policy one, which writes Kubernetes policies as WebAssembly modules. It runs in a controller runtime in your cluster. So we're starting to see WebAssembly with its ubiquitous runtime and embeddable runtime enrich and augment existing what we consider cloud native applications. And I think that may be something we see more and more of as these projects mature, and especially as WebAssembly matures too. But there's also one thing that we haven't seen very prevalent that you two are now working on, which is an enabler and a runtime for WebAssembly or server-side WebAssembly applications to run side by side with containers. And I think this is a very exciting project, and I'd love for you both to kind of share your motivations, a status update, and what's coming next for the project. And of course, introduce it, because I forgot to ask you to introduce it too. So I'll let you take it away.
Yeah, so basically, when I started here with a new job, we had a side project and said, hey, why not use the good old Questlet and put it into a kind cluster so you can easily spin up a Kubernetes cluster with kind, with a Questlet in there, and can run WebAssembly. So we spent a few days, added the kind as a in the kind CLI. So we spent a few days. And we had a kind cluster where you can use the CLI to spin a Questlet as a node. After doing that, we thought, okay, let's try a WebAssembly workload. And then we were, I would say, underwhelmed of the possibilities of the Questlet because we thought it would be almost equal to a kubelet, but you can't really start Linux containers. You can't enable your CNI, so no connectivity. And then we thought that can't be the future of WebAssembly in Kubernetes. Then I've just done some research and put it almost aside and scrolled about the cloud native landscape and found WasM Edge, which claimed to be an OCI compliant WebAssembly runtime. And I thought, that sounds to be good to be true. Can I just plug it into my cluster and it would work? In fact, at this point in time, it was not possible, but we were so close to make it possible with CRun. And CRun has the enabled libwasm Edge. And they have an example in their documentation to make it run with Cryo. And I thought, yeah, but kind is containerd based. Can I do it with containerd as well? Sure, you can do, but nobody has tried so far. So then I added to their documentation the containerd variant of the C1 WasM Edge variant approach, and yeah, it worked. So that was the amazing moment where I thought, why is nobody doing that? Why is not everybody talking about it? We can here have something else than Linux containers. We can run WebAssembly. And the demo back then was an Echo server, but the Echo server could only handle one request at a time. So if you send a second one, you get a 503 because one is already in progress. And then I realized that the way is maybe a little bit longer than I thought. But yeah, this approach evolved. So they got now the async library in Rust with Tokyo and can handle multiple requests with one pod. And also the containerd shims appeared. And then we thought for our demos that it's, I would say, a lot of work always creating a cluster, putting the shims and the runtime in there, configuring containerd and so on. And there we got the idea, why don't do this automatically? And why don't do this automatically on other Kubernetes distributions than kind? And we started experimenting with Minikube, with Microcades, Colima lately, and that were all working. And then our colleague Max approached us and said, can you do this on AWS as well? sure, why not AWS? We create an AMI image, put it up there, create a cluster, it's working. And now Google Cloud. Okay, wait, we can't just have custom images with GKE. And then I read this tiny sentence in the documentation of Google Cloud. If you have Ubuntu nodes, you can just have a root container, escape from your root container, and do something on the node. I thought that sounds too easy. But it is like that. You can just start a super privileged container, escape from your container, and install a WASM runtime on your node. And that's where we started, and just continuing with Azure, which is doing pretty much the same. For EKS, if you have Ubuntu nodes, it's working as well. And DigitalOcean Kubernetes, it's working too. So that was where our installer was born. And short after, we thought we applied it with a daemon set. All nodes at a time. And when I had a typo in my container dconfig, all nodes are gone and can't get up again. So we thought maybe it's not flexible enough. That's why we came up with the operator. And the operator is looking for labels on the nodes. And you can have more fine-grained control when you label what node to get it provisioned. And you have multiple node pools, ones that can run WASM, others that are more classical for classical workloads. And that's how we got this project started.
I think Sven just beautifully described the journey that we had, right? Starting from Crustlet and ending up with our own Kubernetes operator. I mean, in the end, it took a while, but finally we succeeded in like having our with our goal, and we can finally run WebAssembly workloads in the Kubernetes cluster, and like really start experiment with application architectures and things that you can do with WebAssembly right now. And like this is now, it has been easy, and also what you pointed out during this journey, that it was like literally every month or every week, even sometimes, there was another blocker removed. So the beautiful guys from Deus Labs, when we found this container dshim, perfect. We could just reuse it and incorporate it and make it work a little bit more and like to reduce all the configuration that you usually would do. And of course, eventually, ideally, in an ideal world, someday you will not need something like KWasm or this kind of installer, because it's already integrated in your Kubernetes or in your container runtime. This would be, of course, the ideal world, but we are not there yet.
Yeah, and the purpose of the project is just to make it available to developers. So you don't need to be an expert in Kubernetes. You don't need to know anything about how your runtime is called, how the CRI plugins are working. You just put it on your cluster and can start building applications on that. And I think that's the main thing we need right now, applications that are running on this WebAssembly stack. So it's cool that we can do this, but without usage, it's just a fancy demo.
Awesome. All right, let's kind of talk about the container dshim a little bit, because I think this kind of, when people do ask the why WebAssembly, right? We can give them all the best reasons in the world of why we think WebAssembly is cool, but it's through adoption that most people are going to cave and finally say, okay, I better start taking this thing seriously. And I think the container dshim is potentially a pivot point or point of inflection where it's like things really start to pick up for server-side WebAssembly, because what we're seeing now is that Docker, people are saying, why WebAssembly? I have containers. Well, hold on a minute. Docker are now supporting WebAssembly. If that isn't enough for them to go, hold on, wait a minute, this is interesting, I don't know what is. So I guess I think now is where things really start to get interesting for WebAssembly and hybrid architectures with containers. All right, let's ask one more question. And then if there's anything else that either of you would like to cover before we wrap up, we'll do so. But just what is coming next? What blockers are in your way? What needs to change? Or is everything rosy, shiny, and this is what you're going to do for the next 3 months? What have you got for me?
Yeah, so there could be so much we can do. So a big thing is we mainly target Debian-based Linux with container Kubernetes. So I've also, I would say, digged into how it would be with Docker Shim and have I would say, proof of concept that it is possible to use the in Docker included Kubernetes to run WebAssembly containers. It is possible, but it's a very ugly hack. I hope that the guys at Docker are coming up with a better solution. So pretty sure they can do it. On the other hand, there are other Kubernetes distributions that can't run container shims. So everything cryo-based, for example, OpenShift clusters are not really made to use the KWasm installer. So that's something we would look into if that's possible, how it would be the easiest approach to get them enabled, just to get a broader field. But that's only the installer. So what I'm really looking forward to is when the Run Rusty, which the container shims are based on, get more and more features of OCI runtime, like seccomp, like all those things in OCI runtime makes valuable. And there are also people at the moment working on, so really exciting for me. So it's based on Yuki, and Rust implementation of the OCI runtime. And so it's evolving pretty fast. I can't really tell where the future will go. So that's something I always just looking forward to. So we will see. And I hope it will just be more and more adoption. And as I said before, it needs to be applications based on WebAssembly, on containers, on Kubernetes. Without applications, it's just nice to have. But I would say killer app for this platform still needs to be found.
And I would add on this, like, I think the adoption will be mainly driven once the major programming languages are also entirely supporting WebAssembly WASI. So of course it's nice that you can write your WebAssembly stuff in Rust. Rust is a beautiful language, but most of the people don't want to learn a new language just to have a other compile target, right? So for instance, right now, if you want to write Go, you still have to use TinyGo because this is supporting WASI. If you're using the official Go language, it's not there yet, but I saw yesterday or the day before yesterday that there is a new issue created on GitHub where they are finally implementing the WASI spec, which will mean that we can finally, with the official Go version, create WASI modules and write our WebAssembly applications. And so other languages will hopefully follow. And I think this will be one major thing which is required to succeed. In addition, when you take Spin, for instance, I think it's like really going forward, and it shows that you can use something productively and use something already. However, I assume that right now, if you want to use Spin, you still have to use the Spin SDK in your language. And I think WebAssembly will fully succeed once you kind of get rid of the SDK, because everything is a part of the spec. So if you basically don't have to think about okay, against which exact architecture am I compiling against, and I think this will be one thing, like when you don't have to think, okay, I have to compile, I'm writing a WebAssembly application. Like once you don't think about WebAssembly anymore, then I think WebAssembly will actually succeed. Like similar how you today write containers, because you're writing your application, throw it in a container, it will start as long as you expose it to a specific port.
Awesome. Well, thank you very much for joining me today and answering all my questions. Thank you for working on KWasm. I'm very excited for hybrid architectures with containers and WebAssembly. And I'll speak to you both soon.
Cool. Thank you for having us.